Welcome to another Wednesday Widget, folks. I'm super excited. Today we are going to put foot pedals on the Whitney Punch Press. I love this machine. I picked it up used. It is a hole-making monster. For anyone who has to drill holes and things, this thing is a godsend. It is amazing. I use it for the rimfire steel targets that we make. I use it for a lot of job shop stuff. And even when I'm drilling holes bigger than the punch sizes I have or this is capable of, I'll a lot of times punch them as a pre-drill. It's just a great machine. I've done a few videos on it that you can see below here, a general sort of introductory video to it, and then I made a custom stripper plate for it. So I've been super happy with the machine. It's a real tool. It's one of the first things I bought that was a little bit more of the industrial and not the home shop machine type pieces of equipment, but I wouldn't let it discourage you. I have the bigger hydraulic power unit because that's the one I found on eBay for a good deal. I think it was about $1,000. And the punch myself I got for about $700. I had maybe $50 in other hoses and parts I had to get for it to get it up and running. But these new, I think, are over $6,000 or $7,000. Similar type of punches can be had either manually or with iron workers or other competing types of punches, but if you do a lot of hole making, these things are great. Here's what I don't like about it. My power unit has this up and down switch, and it's good in that it works fine, but I don't want to use my hand to control and jog the punch up and down. It's just not efficient, and I actually don't think it's as safe because I want to have my hands and ability to focus on the workpiece and the stripper and so forth, and not be worrying about where's this hand control pendant and up and down and so forth. So I wanted to put a foot pedal on it. Well, I knew when I'd been looking through the Whitney catalog that they sell a foot pedal. So I reached out to them. They're nice folks. I'm not looking to badmouth them, but they came back and it's $1,700 for a foot pedal. Now, what we're going to do today is not apples to apples with what that product would be. And I don't know it, I've never seen it, but no doubt their product is more robust or more thoroughly designed. So this Wednesday Widget is absolutely going to be what I call a hacking video. And hacking is a great word in the sense that it means taking a product and hacking into it and getting it to do what you want it to do. It has nothing to do with a malicious intent. So, on that note, we're going to be getting into the control panel here on this Whitney 3-phase. Now, we need to talk about safety. I think we live in a world that has desensitized realistic safety for the sake of safety everywhere for everything. And I don't like that because what happens is I think folks don't always appreciate where you really do need to be safe and where it's just people that are solving to the lowest common denominator. I had to laugh. A buddy of mine that I've gotten to know works at a local plant that does a lot of hot rolled and pickle and oiling, and they have stupid safety policies. For instance, you cannot back out of a parking space in their parking lot. Seriously, that's a safety rule. You cannot inflate a tire or change a tire in their parking lot. You have to call somebody. There are safety rules relating to inside their shop operation that any common sense person would find moronic. So, this, however, project is going to be an example of where safety is no joke, and do not try to take on any project like this unless you're comfortable with the risks or you get the help of a professional electrician or whoever's the appropriate person that has real skill sets in that. My Whitney phase punch is 240 volts, 3-phase. That's a lot of power, folks, and that's what I'm trying to emphasize here. I love what I do. I can't keep putting out these videos. I can't keep making parts. I can't keep making money if I am dead, am in the hospital with severe medical bills due to some injury, or I lose a finger. So seriously, folks, what you're going to see me do here is, I guess I have to say, do not try this at home, because you have to be very, very safe and you have to be safe. You have to know what you're doing, or you have to get help in doing so. However, that being said, it's a lot of fun, and what we're going to see here is we've got some terminal blocks, and we're going to be able to find out how this switch works, and we're going to be able to use relays on Arduino, and we're going to have our own foot pedal for this thing. Let's dive in. So here we are at our control panel. We're going to open this up. You absolutely have to have this thing unplugged from the wall. I do not care about any excuse, or if it's hardwired, you need to either flip the breaker or even unplug it from the breaker. No excuses there, folks. I guess I am anticipating some folks are going to have an issue with this video or the risks I'm taking. And, you know, it's tough because I understand, again, this is a lot of power, and I'm not a trained formal electrician by any means. But you can do this if you are very, very safe and you understand where not to take risks. And on the flip side, I have to say, look, guys, this is what life's all about. Like, making stuff do what you want. Like, this is awesome, and I think it's incredible that folks that are my age or even younger want to get their hands dirty. They want to make stuff. They want to be involved in manufacturing and the sciences, and less about, you know, desk job type stuff. So if that means everyone gets their hands dirty, and, you know, maybe you get a nick or bruise every once in a while, you know, I'm okay with that. That doesn't mean take 243 phase through your body, because that's not okay. But hacking and experimenting is good, and something that I think our culture has overemphasized safety to the point where people think, oh my gosh, you know, don't void the warranty. And look, you know, I could end up totally breaking this machine, and if I do, guess what? We'll figure out how to fix it. So let's take a look at the electronics here and figure out how we're going to hack this. First things first, here is our control pendant, or up and down switch. We are going to want to take the cover off that so we can look at the switch leads and figure out what exactly these guys are doing. So here's our switch, like so. And what I'm guessing is I'm guessing that we've got two sort of commons here, and when you go up, it'll short two together, and when you go down, likewise. So let's use our trusty multimeter in the continuity setting, and if we touch the probes together, it shorts them out. You hear the beep. Now I'm going to use some alligator clips here because it's going to be too difficult to, unless you have a helper here, to hold the two probes on and push that switch. That switch has got some oomph to it. So let's hook these up here. So I've got one hooked up now. I always test that one. If you notice, I don't have a lot of meat to grab onto there. So I'm going to hold the probe over on the same screw and make sure I've got continuity within that same alligator clip. That works. So let's just put it on a different, oh, I meant to mention too, a great reason why you need to be really comfortable that you've got the skill sets to do this and that you need to get outside help like an electrician is capacitors. This machine doesn't seem to have any, and capacitors, I think all else equal, you know, you don't have a big motor starting capacitor on a three-phase motor generally. I'm not an expert, but that's a great example of where you may have a piece of equipment that's unplugged, but that capacitor still got storage in it, and you absolutely could very likely discharge that cap if you start shorting things together experimenting. So again, I'm trying to balance that line of have fun and enjoy stuff and try to hack it and figure stuff out. It's a great way to learn, and I think it's a great skill set in life, but also be careful. So we'll hold our probe against one screw. No. Yep. Okay. So we know when you go up, it shorts. Ooh, my clip just fell off. It shorts against that. What happens? Okay, that happens as well on both sides. So let's see here. That makes sense because these are jumped together, and the orange is jumped together. So let's think about that. Okay, so what that has to mean, if we think about it, is that up or down, both, there must be two different things here, which is that when you go up or down, both positions short the middle common, I'm calling it, to this orange jumper wire. So let's see here. What that means is that, and let's hook our clamp onto the other side here. So if we hold, we know that center to the white one is up. I'm guessing center to this red one here should be down. It is. It is. So let's make some notes here. We know to go up, it's center to white, to down, it's center to red, and in both cases, and we'll check that here in a second, when you go up or down, center shorts out to the orange guy over here, which looks like it's this orange cable here. Let's double check that again. Make sure I'm not. So one way, beep, other way, beep. Okay, now let's play detective here and figure out where these are back here. We can almost cheat because this panel is labeled, and I have to wonder if that was someone aftermarket. I'd be impressed. Maybe I'm shortchanging them, but I'd be impressed if that came from the factory that way. It's odd because it's pencil too. Anyways, I'm not going to rely on that because I would never trust that, but it'll at least be a helpful way to cheat. The other thing we can do is if you just look at the color of the wires, if you look at this setup, it's unlikely that the wire would be joined somewhere between these 2 points and the color would be switched. So with that, we're going to just use an alligator clamp, and let's find that white one first that we said is the, I think at the up. Oops. That's a hard one to clamp onto here. Okay. Like I said, let's test that. Okay, so we do have continuity. So now we'll go over to our panel here. And it says 7, so we'll try 7. Easy enough. That's nice. So let's find that center common one. Test continuity. So that one is 5. 5. This is going to be really easy, folks. Down is a red cable with a 7. Let's see, is it red? 7. There's the red cable right there. Follow 7 in. Oops. That's dangerous. There we go. Oh, is that mislabeled? It says 7 there. I'm following. I think that might actually be mislabeled. That's a great example. Or maybe I'm. Well, anyways, that's the electrons don't lie. So that's that. And then we need to find this orange one that seems to works on both directions. So the orange one is 9, maybe, or 8. There we go, 8. It's hard to see. I think the panel is correct. It's just I'm sitting a few inches above it. I'll zoom in here. I'm sitting a few inches above it, which makes it easy to misread these, and that's not good. But yeah, that's 8. That's correct. So let's hook up some wires and run a test here. Okay, we've got some wires hooked up. Now this isn't just 18 or 20 gauge wire. When you're hacking, you got to use your noggin. You got to think, and you got to take the clues at hand. You look at this switch. This is not, folks, a little breadboard dinky push button switch. This is a beefy switch, and if you look at the gauge of the wire coming into it, it's beefy. So what this tells us is, when we use Arduinos, a lot of times we're just using logic type switches where you're just saying, hey, go 5 volts high or low, and there's no current there's no material amount of current in them. This is a real switch. This is a current switch, if you will. I don't know what the real name is for it, but when you flip that switch, you're actually passing a lot of current through it. That's probably an expensive switch. So when you look at the wiring here, you'll see it's that same thick gauge stuff. So you can't just use 20 gauge wire. Legit would probably burn up or create a fire. I had a power cable laying around, just an extra, like computer cable one, and I just stripped the sheath off of it, and you've got 3 nice pieces of wire, and they seem to be similar gauge to the stuff we're using, so I'm okay with that. Again, consult an expert if you're not. So let's take a look at our notes here. We think going up would be a short between 5 and 7. So I've got my meter here. Let's grab cable 5 and cable 7. So let's see, we've got 3 here. They're in order, 6, 7, and 8. So the middle one should be 7. So if I hold these two to short these two with our continuity meter. So I've got one of them permanently connected with an alligator clip just for this test. Again, we don't have any power to the machine. And we hold 5 to our other meter probe, like so. and we go up, I said. Let's see here. So up, we get a beep. Down, no beep. Oops. Down, no beep. That's a great example. I held this piece against the casting here, and it shorted out. So that's why you don't have any power on right now, and that's a good example how you got to be safe when you actually start hooking power up. Okay, 6 and 5 should be down. So I'll leave 5 here. I'll swap this one with 6, which is a green one. Up should be nothing. Great. Down should be a beep. It is good. And then I was saying 5 and 8 will be shorted on both up and down. And you know, I wonder what that is. My guess, and I wish I knew more about hydraulics, but my guess is the up and down switches are direction, and then the 5 and 8, which goes with both up and down, is the power, if you will. Be curious to see what folks say. So 8 is our black one. Boom, boom. Okay. And so 5 and 8 on both up and down. Okay, I am happy with that. Let's go talk Arduino.